Hey everyone, welcome back. For this session, we're going to be taking a look at loops. So let's go ahead and jump in. First, let's start with a review. So design a change counting game that gets the user to enter the number of coins required to make exactly $1. The program should ask the user to enter the number of pennies, nickels, dimes, and quarters. If the total value of the coins entered is equal to $1, the program should congratulate the user for winning the game. So basically just output something that says you win. Otherwise, the program should display a message indicating whether the amount entered was more than or less than $1. So pause the video, take a look at these requirements and try it yourself, and come back and we'll do it together. Okay, so in the editor here, I've already copied and pasted all the requirements. I'll go ahead and paste in. So first thing we want to do is get the inputs for all of the different coins, which I'm doing right here. So it's just int input for all of them. So once we've gotten all of the inputs, right, we need to do some math to determine how much the user has actually put in. So here we can say total pennies is equal to pennies times, like so. And we can do the same for all the other coins. Okay, so once you've gotten all of these, what we want to do now is add them all together to get a grand total. Okay, so once we've got our grand total, now the point of the game is to get $1 or tell the user they put too much or not enough. So let's go ahead and write out these conditional logics. Oops, 1.00. So first, is it greater than $1? Print too much. Elif elif grand total less than $1, print not enough. And lastly, if it's neither too large or too small, it's just right, which means they win. Okay, so let's see how we did. So first, I'm going to make this equal $1. So 0, 0, 0, and 4 quarters. Perfect. Okay, so let's go ahead and make it too small. So 1, 1, 1, and 1. Okay, and lastly, we need to make it too big. So 101, 0, 0, 0. Okay, I'd say we did a pretty good job. So there is a couple of ways to go about this. You didn't necessarily have to create these variables. You could have just put all these calculations right here on this line. In fact, let me go ahead and show you that. So let me go ahead and get rid of this. So I'm going to cut that. And I'm going to put it in parentheses because I think it's just clearer that way. But by order of operations, not required. Like so. And that's totally fine too. You could also do something along the lines of creating a variable to hold what the threshold is, right? And that'd be acceptable. Makes it easier to change in one place versus two. And then you could also have constants for these. But otherwise, this looks good. And then there's a sample solution here as well, if you like taking a look. So on to the topic for tonight, which is loops. So loops allow us to repeat logic. And there are two looping mechanisms in Python. The first one is a while loop, and the second one is a for loop. The while loop is going to loop as long as a condition is met, whereas the for loop is going to loop for a set number of times. So the first one we're going to look at is the while loop. So while loops are known as precondition loops, meaning that they will check the condition before they run. So for example, if I say that the condition is 1 equals 2, right, it'll check that and say, well, that's not right, and it won't loop at all. So that's what it means when it's a precondition loop. So the general syntax of a while loop is the keyword while, the condition, colon, and then the statements beneath it that you want to repeat. So here we have 3 statements that are indented, which indicate that they are part of the while loop logic. And then we have that last statement that's not in the loop because it's not indented. So here's an example. So I have x equals 0, while x less than 10, print x is equal to, and then x. And on line 4, I'm doing x equals x plus 1. So take a second and think about why we might have to do that. So the answer to that is because if we do not increment x, then x will always equal 0. And therefore, x is always going to be less than 10, which means the loop will never end. So don't forget to do that when you're doing your loops, especially when it comes to writing your own count control loops like this. So you can also shorthand the x equals x plus 1 by doing something like this. So on the right side here, it's x plus equals 1. So just a little shorthand notation. And we can see here on the output, x is 0, 1, 2, all the way to 9. And then when x is finally equal to 10, it breaks because x is not, 10 is not less than 10. Okay, so time for a review, kind of what we just did. So develop a program that asks for a user to enter an integer, then print the numbers 0 through that input and display whether they are even or odd. So take a second, pause the video, and take a stab at it. Okay, so let me go ahead and grab this. This is the directions. I'm gonna go ahead and paste it in here. Whoops, wrong key. There we go. And I'm gonna go ahead and put this on 2 lines. Okay. So first thing we need to do here is ask for that integer. So here we're going to say num equals int input enter number to loop 2. Okay, so now we want to loop from 0 up to that number. So if we're going to use the while loop we just saw, we're going to kind of do the exact same logic, which is x equals 0, while x, and then what does it have to be less than? Right? So in this case, we want to go up to the number the user entered, which in this case is num. And then just so we don't forget, x plus equals 1. Okay, so here's kind of the basic while loop here. And now the logic that we have to implement is whether or not the number that we're looping on currently is even or odd. So to accomplish that, we're going to have to use the percent sign, which is also known as the modulo operator. And that's going to give me the remainder after a division. So we can use that to find even numbers if a number modulo 2 equals 0, right? So it's evenly divisible by 2. So let's go ahead and do that. So if x modulo 2 equals 0. If that condition is true, the number that x currently is even. So print, I'm going to use the F formatter here. X is even. And now this is a binary choice, right? It's either even or it's odd. So in this case, I'm going to say else. And then print F format, X, oops, not a capital X, just a regular X, is odd. Okay, let's go ahead and run it. Now I will go ahead and bring this up a little bit. So let's go ahead and just go to 10. Okay, looks good. And that accomplishes the task. And then there is some sample code here. And it might look almost exactly like we just did. Okay, another review problem. Create a list of names. Using a while loop, iterate through the names and display them. So let's go ahead and grab the directions. Okay, so pause the video, take a second, and see if you can take a stab at this. Okay, so we need to first create a list of names. So I'll just say names equals Will, Tom, Jerry, Sarah, and let's just put one more, Susan. Okay, so we need to loop and display these names. So first, I'm going to say x equals 0, while x is less than, and what is it that it has to be less than here, right? So if you want to go through the list of names, right, then it has to be less than the length of the list, right? So if you recall during our list lecture, I said that the len function is probably going to be important. So in this case, we're going to say while x is less than len of names, x plus equals 1. Okay. So in this case now, we know that lists are index based, right? And we can use x to access the list by index. So I'm going to say print names of x. Okay, I think that accomplishes it. So let's go ahead and run it. And there we go. Will, Tom, Jerry, Sarah, and Susan, all of them printed out. Great. And then here's a sample solution. Okay, moving on to for loops. So for loops are also precondition loops. And the general syntax for a for loop is for variable in condition. And then in this case, we have 3 statements that are inside of the for loop, and we have 1 statement outside of the for loop. So when it comes to doing something similar to our first kind of exercise that we did in the while loop, we have to use the range function. And range is a function that yields a series of numbers. So it defaults to starting at the number 0. And then the default iteration is by 1. So on the right side here, we can see the screenshot, and we see 4x in range 5. So that means that this is going to count from 0 to, but not including, 5. So then 2, print x equals, and then you can see here x is equal to 0, 1, 2, 3, 4. And then once it hits 5, it no longer loops. One thing to also note here is that you don't see an initialization for the variable x. You don't see a incrementation for the variable x. Well, that's because the for loop is smart enough to kind of handle that all for you. So the only thing you have to worry about is naming it. So for x, it could be for n, it could be for I, it could be for raspberry in range, whatever you want to call it. The for loop will automatically increment it for you. You can also pass a second argument to the range function, and that was to say go up to this number from this number. So for example, if I put range of 1, 6, it'll start at 1 and go up to but not include 6. And then lastly, you can pass a third argument to iterate by a different number. So basically the step that you want to be iterating by. So for example, if I say range of 1, 20, 2, it'll start at 1 and then count by 2. So the output would be 1, 3, 5, 7, 9, 11, 13, etc. So we have a review here now. So given an integer input, print all numbers from 0 to the input. And for this, let's assume we're going to use a for loop. So for multiples of 3, display fizz. For multiples of 5, display buzz. For multiples of 5 and 3, display fizzbuzz. For all other numbers, print whatever their value is. So 0, 1, 2, whatever it may be. So take a second, pause the video, try it yourself, and then we'll do it together. Okay, so let me go ahead and grab the directions. I will comment them out. Okay, so first we have to get an integer input. So here we're going to say num equals int input enter number 2. Okay, so we want to loop from 0 all the way up until whatever that number is, right? And we're going to use the for loop. So in this case, we know that we have the range function available to us in the for loop so that we can start from 0 up to whatever the number is. So in this case, I'm going to say for, and I'm going to use x. So for x in range, range. And then what are we ranging on? Well, it's whatever the user input. So range num, like so. So from 0 until whatever the user entered. Okay, so now we have to start doing some conditional logic to display fizzbuzz, or just the number itself. So what you want to do first here is the most specific conditions first, which in this case is going to be for multiples of 5 and 3. And how do we determine the multiples of 5 and 3? Well, kind of like what we saw with the is it evenly divisible by 2, right? We want to do that same thing for is it divisible by 5 and is it divisible by 3. So in this case, it'll be if x modulo 3 equals 0 and x modulo 5 equals 0, right? So it's both of them evenly divisible by. Print is elif x modulo 3 equals 0, right? So in this case, modulo 3 or modulo 5, it doesn't really matter which one comes first because one is not necessarily more specific than the other. So, but if it's 3, print is elif x modulo 5 equals 0, print buzz. If it's not divisible by any of these things, print x. Okay, and I think that takes care of it. So let's go ahead and run it. So we need a number large enough to where at some point we're going to hit fizzbuzz, right, as an output. In that case, the first number we're going to hit is 15. So I'm just going to put 20. So fizzbuzz on 0, and that's okay because 0 modulo 3 equals 0. I mean, it sounds wonky, but sure, it works. Then we have 1, 2, fizz, right, because 3 modulo 3 is 0. 4, buzz, right, because 5 modulo 5 is 0. Then we have fizz again for 6. 7, 8, 9 is fizz. 10 is buzz, right, because one modulo 3 is 0, and then the other is modulo 5 is 0. 11, 12 is fizz. 13, 14, and then 15 is fizzbuzz because it meets both of them. 16, 17, 18, right, is fizz, and then 19, and then at 20 we stop. Awesome. So sample solution. Okay, so for loops have some helpful functionality that aren't available in while loops. So let's loop through the name list again, and this time with a for loop, right? So we have a little snippet here. So we have names equals Will, John, Sarah, and Sam. And here I'm saying for n, right? So again, that variable can be whatever you want, in names. So in this case, n is not going to be assigned the index of whatever position it is in the list. It's actually going to be assigned the element itself and iterate through the elements. So printing n will be Will, John, Sarah, and Sam. This applies to tuples as well in the exact same way. And it also applies to strings, right? So if you said for, s in my string, it'll iterate through the individual characters of your string. Another helpful function for iterating on lists and tuples is the enumerate. And the enumerate is going to give back the index and the element itself. So in this case, it's for idx comma n. So notice here that we have two variables now. And that's because the enumerate will first give you the index, which in this case, I'm saving it to idx, and then it will give you the element itself, which is being saved to n. And then when I print index and I print the n, notice here, index 0, Will, 1, John, 2, Sarah, and 3, Sam. So really helpful. For loops are also helpful for dictionaries. So by default, if you just do something like 4K in profile, right, in the screenshot here, so by default, it will iterate through the keys. So the output for printing on K is going to be name, age, and position. Dictionaries provide a couple of helpful functions to help you kind of do your looping. The first one we will look at here is dot values. So what that's going to do, it's going to give back the values instead of the keys. So giving out a little snippet here, if I did 4K in profile dot values, instead of printing name, age, and position, it will print Will 30 in programmer. And that last line there is dot items. So the dot items will iterate through the entries, so keys and values together. And in that case, you would need two variables. So here, the second snippet screenshot here on the bottom is implementing that on that profile dictionary. So 4K, comma V in profile dot items. So the K in this case, so the first variable is going to be assigned the key. The V is assigned the value. So when I print K and print V, you can see that K will be name, age, and position, and V will be Will 30 in programmer as it iterates. Okay, so let's go ahead and do a review. So there's two problems here. So make a program that outputs the following. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. That doesn't have to be that exact thing. I really care more about whether or not you get the concept down. So take a second, pause the video, and go ahead and take a stab at that problem. Okay, so let's go ahead and switch over to the editor. I'm going to drag this down just a little bit. So unfortunately, I can't copy this screenshot over, but I'll probably keep toggling back and forward here. So we need to do 1, 2, I'm sorry, 1, 1, 2, 1, 2, 3. So in this case, like I said, it doesn't have to be that exact output. So I think a list is appropriate here. So I'm going to say nums equals, and then we'll just put empty. And then I'm going to say here for, and I'll say I in range, and I think we're going up to 5. So, and I think it's 5 inclusive, correct? Yeah. So I'm going to go to 6, right? Because remember, it goes up to but not including. I'm going to do nums dot append I. And then I'm going to print nums. So if you did this, this is totally okay. This is kind of what I would expect. Go ahead and run. And you'll see here, whoops, we have 0s in there too. So we don't want to include 0. So in this case, instead of saying start from 0 and go to 6, I'm going to say start at 1 and go to 6. All right, let's try that again. There we go. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. And that's totally okay. Now, if you want to clean it up a little bit with some string functionality and such, I have some screenshots here that kind of demonstrate some different functionality that you could have done. Okay, next is make a program that accepts a string input and outputs the reverse without using any reverse built-in functions. So if I put William as the input, I should get an output of whatever that word spells, but M-A-I-L-L-I-W. So go ahead and pause the video, take a second, and take a stab at it. Okay. So, oops, come on. There we go. First, we need to get an input of some kind that we need to reverse on. And in this case, we saw that it was a string, so we don't have to do any casting like an integer or a float. So we'll just say the user input. So user input equals, and then we'll say input, enter text to reverse. Okay, so now I think probably the easiest way to go about this would be to go backwards. So in this case, I'm going to say x equals 0. Sorry, len of user input minus 1. So x is going to start off right at the end, right? So we're going to make it a larger number than 0. While x is greater than or equal to 0. Then here I'm going to do x minus equals 1. So I'm actually looping backwards, right? So counting down instead of counting up. So what kind of logic do we have to put in the middle now? Well, I want to print the individual characters of whatever it is that the user has input. So in this case, I can say print, and then we'll say user input of x. Now, if I do this, the print is actually going to print them on completely separated lines. So I'll go ahead and run that just to show you. Right? So we don't want to do that. We want them all nicely together, just as if the word was in line together. So the print can actually take a end equals like this. And that says, hey, instead of the normal ending of a new line, I'd like you to use this instead. Let's go ahead and try it again. And there we go. And that accomplishes that task. And a very similar solution here. Okay, so lastly, the last thing we want to cover as far as loops go is flow control. So we are able to manipulate the flow of a loop using specific keywords. They are break and continue. Break is going to stop the logic immediately and break out of the loop. So here on the left side screenshot, we have x equals 0, while x less than 10. If x equals 6, we're going to break. And then print all done at the end. So notice here, if we run it, 0, 1, 2, 3, 4, 5, all done, right? So it never made it up to 10 like the loop is checking for, right? And that's because on line 4, we broke out of it when x was equal to 6. So that break stops logic altogether and says, okay, we're done looping altogether, move on. On the right side there, we have the continue keyword. And the continue is going to skip to the next iteration of the loop without completing the logic for the current one. So here we have the similar logic, right? Except for the x plus equals 1 has been moved. When x is equal to 6, it's going to continue. So here on the output, it's 1, 2, 3, 4, 5. And notice there's no 6, 7, 8, 9, 10, and then it's all done. So the reason why we had to move that x plus equals 1 to the top there is because if we didn't, x would always equal 6, and thus the loop would never end, right? It would always hit that continue keyword and continue looping, because it would never actually get to x plus equals 1. And that's all I had for you on loops. So hopefully you enjoyed the lecture, and I will see you next time.